class, we are now on 5.5. This is distinguishing ionic and covalent compounds. So this is more just a review to go over each. In order to fulfill an octet rule, atoms can either gain or lose electrons to form ions or share electrons through covalent bonds. In covalent compounds, atoms share electrons through covalent bonds. I just said that. Covalent compounds form between non-metal atoms. These compounds form distinct units called molecules. We generally describe covalent compounds using molecular formulas that indicate the exact number of each atom contained in one molecule. Ionic compounds are formed between oppositely charged ions that, ionic compounds do not form discrete molecules. They form 3D frameworks of alternating positive and negative charges. That's the ionic lattice structure. We describe ionic compounds by its formula unit or its empirical formula. That is the simplest whole number ratio of cations to anions in the compound. Think of sodium chloride. We don't say there's like 2,300 sodiums and 2,300 chlorides. We do 1 and 1 because that's the smallest unit, formula unit of that compound. So the differences in ionic and covalent bonding lead to many unique physical properties. Limestone is composed of calcium carbonate, an ionic compound. Olive oil is composed of covalent molecules containing carbon, hydrogen, and oxygen. The properties of any compound, from a hard solid like limestone to a liquid like olive oil, arise from the types of elements and bonds that are present. It is important to be able to distinguish between ionic and covalent compounds. You need to be able to identify the elements present, and you need to know whether they're a metal or a nonmetal. So the first thing is the compound composed entirely of nonmetals? If so, it is a covalent compound. The next thing you might want to ask yourself is it composed of metal and a nonmetal? This indicates it's ionic. So these are the things that would help you. Does it contain any common polyatomic ions? If it does, it's ionic. So let's look at these examples. So we have MgF2. That's magnesium fluoride. We have a metal, which is magnesium, and fluoride, which is a nonmetal. So this is an ionic compound. Next, we have P2O4, which is diphosphorus tetraoxide, and it only contains nonmetals. Not to mention the fact that we're using di and tetra, that's only used for covalent. So covalent compounds use prefixes to indicate the number of each atom present. Diphosphorus tetraoxide. Now we look at this bottom one, which is Fe, in parentheses we have nitrate. This contains a polyatomic ion, the nitrate ion. It is an ionic compound, and we name this iron 3 nitrate. Atoms like iron have multiple cations, different charge states. We named the charge in the parentheses after which charge state it is. And remember, there's no space in between the parentheses. SCl6, this contains only nonmetals. So it's a covalent compound, and this is sulfur hexachloride. The first element, the prefix mono, is not necessary, and we do not use it. And that is, so let's go through some of these. Identify each compound as ionic or covalent, and name the compound. So let's take a look. I'm just going to cheat here. Cobalt 3 fluoride, that's ionic. That's a metal and a nonmetal. SO3, that's covalent, sulfur trioxide. IF, that is covalent. That is iodine pentafluoride. Iodine is lower on the periodic table, so you would say that first before fluoride. Sodium sulfate, ionic because we're dealing with the polyatomic ion there. Which of these is not ionic? I'm just going to cheat. PBr, phosphorus tribromide. That is 2 nonmetals.